You can use common factors and the distributive property to create equivalent expressions. In doing this, there are 3 steps you need to follow. But it will make a little more sense if you think of the problem as a word problem. Now we're going to look at this problem here, 36 plus 27. These are just numbers. It's a numeric expression. But what I want you to imagine is, imagine this is referring to 36 dogs and 27 cats. Now this is not a word problem. These labels are just here to help you make sense of what it is we're doing when we create our equivalent expressions. So the first step in creating equivalent expressions is to list all the factors of both numbers. So I'm going to start with 36, and I'm going to list my factors. I have 1 times 36, I have 2 times 18, I have 3 times 12, 4 times 9, and 6 times 6. And then I'm going to do the same thing for the 27. So factors of 27. I have 1 times 27, and I have 3 times 9. So step 1 lists all of your factors. Step 2 is we want to circle all the common factors. So if I look, both of these have a common factor of 1. They both have a common factor of 3, and they both have a common factor of 9. Okay, so we list the factors, we circle our common factors, and the last thing we're going to do is write our equivalent expressions. Now our equivalent expressions are going to come from these common factors. Let me show you. The first common factor we have is 1. The 1, the common factor, is going to go outside our parentheses. This common factor represents how many groups I can make. Okay, I could make 1 group. Now, the other factor we have that matches, okay, in this case with this one, its matching factor is 36, and this one is 27. Those other factors are going to go inside our parentheses. So let me show you, and then I'll explain what it means. So I had 1 as my common factor. That's outside my parentheses. Then inside, I'm going to have this 36 and this 27. Essentially, what this expression is telling me is how many groups I could make. This number here, 1, means I could take my 36 dogs and 27 cats and break them into 1 group. If I had 1 group, that group would have 36 dogs and 27 cats in it. Now let's look at my second common factor here, 3. This common factor, 3, means I could break these animals into 3 groups. If I broke them into 3 groups, each group would have 12 dogs. So I'm going to take this matching factor with my 3 times 12, and say if I had 3 groups, there would be 12 dogs in each group. And then I'm going to go over here. If I had 3 groups, there would be 9 cats in each group. So this equivalent expression is like saying I have 3 groups. Each group has 12 dogs and 9 cats. And then finally, let's look at the last common factor I have is 9. That's like saying I could break these animals into 9 groups. If I did that, the matching factor for the dogs is 4. If I had 9 groups, each group would have 4 dogs. And if I had 9 groups, each group would have 3 cats. Okay, this is our distributive property. What we've done is we've created equivalent expressions. And what I want you to notice is if you take your factor, your common factor, and you multiply it, you're going to end up with the same things you started with. Like if we look at this, if I do 1 times 36, I get my 36 that's over here. 3 times 12 is 36, and 9 times 4 is 36. Now if I do the same thing for my second factors, 1 times 27, 3 times 9, and 9 times 3, they all equal the second number I have in my expression. And that's how we can tell we've created equivalent expressions. All right, let's try it again with another set of numbers. Remember, step 1, list all the common factors. So I'll start with 12. I have 1 times 12, 2 times 6, and 3 times 4. And then I will list my factors for 18. And I have 1 times 18, 2 times 9, and 3 times 6. My next step, circle all the common factors. They both have a 1, they both have a 2, they both have a 3, and they both have a 6. Now it's time for me to write my expressions. The common factor, remember, the common factor goes outside the parentheses, and the other factors go inside the parentheses. So here's what we have. Let's start with my common factor of 1. Okay, 1 is matched up with 12 and 18. So inside I'm going to have 12 and 18. My next factor that I have, common factor, is a 2. So my 2 goes outside. 2 is matched up with 6 and 9. So inside I get 6 and 9. My next common factor is 3. 3 goes outside. It's matched up with 4 and 6. So 4 and 6. And finally, my last common factor I have is 6. So 6 goes outside my parentheses. 6 is matched up, if I look, with 2 and 3. So 2 and 3. Now the order is important, okay? Remember, when you double check, if you take that common factor and multiply it by the first number, it should equal your first number. So it's important that the factors you list first are factors of your first number here. The other thing to keep in mind is that this is an addition sign because we had an addition sign in our problem. If our problem here had said 12 minus 18, then all of these would also be minuses. Okay? So that's how we use common factors and the distributive property to make equivalent expressions.